Good morning, good evening, or good afternoon, depending on where you're joining us from today. We would like to welcome you to today's session of the Azure webinar series. Our topic today is Develop IoT Solutions with Analytics and AI on your devices using Azure IoT Edge. Before we get started, let's go through a little bit of housekeeping. First of all, there is a Q&A box on your webinar console, and at the end of this webinar, we will try to address any questions you might have related to the topic. So go ahead and pop those questions into that box if you have those along the way. In addition, on the right-hand side, you're going to find a Resources tab, and in that Resources tab are URLs that we think you'll find useful either during or after this presentation. In addition, you will find a survey. We are hoping that at the end of this webinar, you will pop into the survey and give us some information about you and what you thought of today's presentation. You will receive a recording of this webcast in your email within about 48 hours, so please keep your eye on your email for that. I would like to introduce our speaker today, Olivier Bloch. He is a Senior Program Manager with Azure IoT. And Olivier, I will hand it over to you.
Thanks, Pamela. Thanks, everyone, for joining. So as Pamela mentioned, I'm part of the Azure IoT team, and some people might know me because I'm running a show online. There's tons of interesting information about Azure IoT on Channel 9. So if you are interested in learning more about Azure IoT in general, I do my shameless plug at the beginning, which is about joining the Channel 9 IoT show. Today we're going to talk about IoT Edge and how you as a developer or as an engineer, you can take advantage and run machine learning algorithms, very rich analytics as close as possible to devices using Microsoft Azure IoT Edge. And before jumping into a demo to show you a few things, I want to go through a couple of slides that explain what IoT Edge is about, what we're trying to achieve with it, and then talk about the concepts that you need to understand and grasp when it comes to developing for IoT Edge or with Azure IoT Edge. That's not the session you're in for. Stay, because it's going to be fun. So the first thing I want to bring up to your attention is why would we need to do compute and analytics at the edge? When we say at the edge, we're not talking about the browser. We're talking about devices. We're talking about what's going on site, on premise. And the idea with IoT Edge is actually to complement the IoT in the cloud. When you are in the cloud, what you can do is implement remote monitoring and manage your assets. You can actually merge remote data coming from multiple IoT devices, and you can do analytics on them. And then you can benefit from the infinite compute and storage to train machine learning and other advanced AI tools. On IoT Edge, what you can start doing is benefit from low latency, tight control loops, where you need to have a real-time response. When you want the data to go up to the cloud and then come back, you can benefit from, my bad, we are having the slides are running automatically here. So we'll complicate with that. Sorry for that. So I'll try to keep up on the slides that are rolling on their own. IoT on the edge, actually, you'll also be able to do protocol translation. For devices that are not able to talk automatically or to talk directly to the cloud, you're able to translate their local protocol into something that is compatible with the cloud. And also, you can keep the data on premise. All of that ensuring that you have symmetry between what's going on in the cloud and at the edge. So as a developer, what you care about is the operational patterns for IoT Edge, right? What can you implement as a solution benefiting from IoT Edge? The first thing is deploying intelligence at the edge. So you can start running machine learning, AI, stream analytics at the edge directly on devices. I just mentioned you can translate protocols as well. Last but not least, you can do on-prem data aggregation and analytics. So you can keep the data for privacy reason or IP reason on-premise and do your analytics directly on these devices. So you don't have to send the data up to the cloud to get insights into your data. The other question I get very often is what devices can this run on? And I'm a bit jumpy on my slide. I'm sorry for that, guys. Don't go away. So in terms of devices that IoT Edge can run on, today, the way we implemented IoT Edge requires to have Linux or Windows on x64 or ARM type of devices. So basically, if you ask me, can I run that on Raspberry Pi? The answer is yes. It's based on containers technology, on Docker, so we'll talk about that a little. But don't expect to run IoT Edge on devices that are constrained or very tiny like sensors. You need to have something that we qualify as at least as an interactive tier device, Raspberry Pi being, on the low end on that, of that scale. Let's go through some of the concepts of IoT Edge. These are very important for you to understand how to use Azure IoT Edge. The first concept that I want to bring up is called module. A module is basically based of several things. The first one is an image. That's a container package that the software is in and that defines the module itself. That's the code, right? A module instance is a specific unit of computation running that image, that module image, on an IoT Edge device. That instance is started by the IoT Edge runtime that we talk in a minute. Then you have the notion of identity. Each module that is running on an Edge device has its own identity, and that's stored in the Azure IoT Hub service. Last but not least, we have the module twin, which is a representation of the module status in the cloud. The other concept you need to understand is the IoT Edge runtime. So the runtime is the one that's going to run the modules.
Let's move to a slide a little bit forward in the deck. Let's get you back on track here. Just 1 second.
Sorry for that, guys. Just 1 second.
Hold tight for 1 minute. All right, we're just getting the slide deck back on track here, and we will be right back with you.
Sorry for the intermission. I hope you got popcorn in the meantime, but let's continue that story. So IoT Edge runtime is that second concept that you need to grasp about IoT Edge. So the runtime itself is the one that installs and updates the modules on the device. So that's something that's running on your Edge device that you control, as you'll see during the demo, and that will interact with IoT Hub to get its configuration, download the modules, and run them. It maintains that IoT Edge security standards on the device. That's the one that guarantees that the pieces of software that are going to run on it are who they say they are, and guarantees the integrity of the data they're managing and so forth. It also ensures that the various modules, the various compute units they're going to be running, are always running. It can also report to the IoT Hub the health of each of the modules. So that means that you can visualize and monitor the health of your various software entities running on your Edge device in real time from the IoT Hub service. It also facilitates communication between downstream leaf devices and the IoT Edge device. So if you have leaf devices such as sensors that don't have network connectivity and cannot connect directly to IoT Hub, what you can do is connect them to IoT Edge, and the Edge device will act as a gateway for these leaf devices. It also facilitates communication between the modules. As you'll see in the next slide or so, we have that notion of communication between modules through inputs and outputs. And then the IoT Edge runtime is the one that decides, or by configuration, implements that communication between modules. This module output will talk to this input in that other module. So that's what you're doing when you're configuring the IoT Edge runtime, is defining the routes between the modules. It also, last but not least, facilitates the communication between the IoT Edge device and the cloud. That's the owner of that communication with the cloud. When you build a module for IoT Edge, you don't mind, you don't care about the communication with IoT Hub, and you communicate to the Edge runtime with the other modules. And then the edge runtime itself establishes the secure connection to IoT hub and that communication up and down. So the concept of routing I started talking about is that notion of allowing the modules to talk to each other. So the typical scenario is to have a module that produces data in your infrastructure. Let's say we have, for example, a Bluetooth low energy module that can receive data from that BLE sensor. It will inject the data into the edge runtime through one of its outputs. And then because there's a route that's been defined in a runtime, we'll have a second module that's going to pick up on that message, implement any sort of analytics you want to implement, and give that data analyzed back to the pipeline in the edge runtime for eventually uploading to the cloud or doing something else with it. For defining a routing, we're using a query language, which is very similar to SQL. You define a source with a from statement, then a condition with a where statement, and then a sync with the into statement. So you go from somewhere to somewhere else when you have a specific condition. The type of sources usually are the outputs of the various modules. And the modules are defined with that semantic here with messages / modules / the name of the ID of the module itself / outputs / the output name. You can use a star statement here for all outputs, for example. The condition is a very simple syntax with something such as sensor type equals temp, and it actually looks into the properties of the message or the body of the message to find this information. If you have a message that contains a property in the header of the message that is alert equals true, then you can use that property to route the messages between modules and totally control that flow of data. The syncs are the destination for the messages when you define the routing. Upstream, with a $sign in front of it, is for sending data up to Azure. The broker endpoints is the function that allows you to find the inputs for the various modules that are running on the device itself, with the same syntax where you point to a module, module ID / inputs, and then pick one of the inputs. For these broker endpoints, you cannot use the star to send an info to all the inputs of a device. You have to specify a specific input. So here's an example from messages, modules, module 1 output star, where sensor type equals temperature. We will send this, the runtime for Edge will send these messages to the broker endpoint, which is the module 2 input 1. So it's pretty straightforward, and you'll see in the demo we'll use that routing syntax in order to implement some smart thing there. Last but not least, in terms of concepts, it's important to understand the various personas that are working with AzureIoT Edge. And while we are naming them developer and operator, that's really for a mental model because everyone is a developer, everyone is an operator, but you have different ways, these two ways to interact with IoT Edge. The developer is the one who is familiar with dev tools. He's coding. He's developing and testing modules. He's developing and testing pipeline of data. He's the one who is actually creating the various bricks that you're going to put together on IoT Edge, so the various modules. And then he tests all these modules all together. And that's the one that actually also does the continuous iteration and integration of his development. The operator is the one that's going to bring that development to scale. The developer works on one edge device, few modules, tests them, eventually tests some scale with simulators, but then the operator is the one who takes that development, these modules, and starts managing a large fleet for them. Starts managing lots of IoT Edge devices, starts managing deployment at scale on various devices, staging the deployments, and verifying that everything is healthy and working correctly. Both use the same kind of tool, the same interfaces, but in a different way. All of that put together looks like this. In terms of the principles for making IoT Edge work, you have this notion of containers that are in the cloud where we store the various modules. So this is where we as a developer are going to go shop for modules that do, for example, anomaly detection or something like a smart cognitive service API. Or this is where, as a developer, I'm going to push my own modules. If I developed a nice Modbus module that will translate data coming on a Modbus network onto my edge device, then for that to go to the cloud, I can publish that module as a Docker container on a container registry, private or public, for it to be used by my operators or other developers. The first thing that the IoT Edge operator will do when working with IoT Edge and IoT Hub is provision an edge device. So basically, define that there's a new edge device that needs to be created in the IoT Hub as an identity, and then define what kind of agent it needs to run. So the agent is part of the runtime, and is basically running on top of ARM or on top of x64 machines on Windows or Linux. So this is the kind of agent that you want to run on your device, right? So you're basically defining that. Then you're going to select the edge node you want to deploy to. So you will say, hey, which of these edge devices do I have in my IoT Hub that I need to deploy that runtime to? Once the runtime is running, what you need to do is define the modules that will be running on that very node, on that edge device. So we're using in the backend the device twin of that IoT Edge device to define the modules and to define the routes between these various modules. The runtime itself will download these containers as defined in the device twin and will run them locally on my edge device. Then what you can start doing is working around with the routing and the various twins for the modules to start doing configuration. Each of the modules, they have their own twin, so you can define configuration for each of these individual containers or individual modules for them to implement the logic that you decide. All of that goes through Azure IoT Hub. So you have an interface with APIs or with the Azure portal that allow you to go through all these settings programmatically or visually. Then you're going to start looking at how do I connect my actual devices. So you have your runtime running, you have your various modules and containers. You can start connecting actual leaf devices, or you can connect these devices that require to have protocol translations onto the IoT Edge one. So this is the big picture of what IoT Edge in action looks like. In order to do all of that, here are your tools. The first one is the Azure portal, and I'll show you a little bit how that works for creating a new edge device and configuring an edge device. But that doesn't scale, so we do have other tools for you to play with. In terms of command line interface, you'll start with the Azure CLI 2.0, which is a Python-based tool, and we now have an IoT extension for it. And you can find that on GitHub or also on the IoT registry for the Azure CLI. On the extension registry for the Azure CLI, where you can add the extensions directly from Azure CLI. But in short, go to GitHub/Azure/Azure IoT CLI-extension, and you'll find this new extension that allows you to interact with IoT Hub in terms of setup. And you can script that to go beyond just one IoT Hub, obviously. Another tool I want to bring up is called the Azure IoT Edge Dev tool that's been created by one of our engineers, which will specifically work on enabling edge scenarios in the Azure CLI tooling. So create a solution with various modules in there, do CI/CD for continuous integration and development of your code for modules. Another tool that's going to be very useful, I'm going to use in the demos today, is Visual Studio Code. That comes with a couple of extensions that you'll find very useful. In addition to the fancy tooling, we are providing SDKs. So the SDKs are used for developing modules. They are very similar to the ones that we have for connecting devices directly to IoT Hub. As a matter of fact, they are the exact same ones with some specificities to modules, which is instead of having and dealing only with a device ID, they can deal with device ID and a module ID. And the other thing is they can deal with the connectivity which is not with IoT Hub, but which is with the Edge runtime. But in terms of development, if you've been writing code for connecting devices to Azure IoT Hub, you'll feel very familiar because these are the exact same APIs with the exact same code base for the SDKs. You can also consider developing and debugging in your favorite language. So because we're still in preview, we have C# and C only release for now, but soon you'll be able to build module using Python, Java, Node.js. Note that it doesn't matter if a module is written in one language and you want to run other ones in different languages. The IoT Edge runtime itself establishes the communication in between the modules, allows them to run in their own sandbox, and you don't need to have the same language for all of your modules. As a matter of fact, you can also have some of your modules that are running on Windows, Windows guest OSs in terms of containers, and other ones running Linux. So you can start mix and matching thanks to both Docker and the IoT Edge runtime technologies, the various languages you can use. And you will build containers the way you build containers for Docker. It's pretty straightforward. What we add is a SIM layer through the SDKs that allow these containers to communicate with the Edge runtime. We also provide some built-in, or let's say already pre-configured packages for you to use. One of them is based on Azure Stream Analytics. Developing rich analytics, near real-time analytics in the cloud with Azure Stream Analytics is something that is very powerful. We've been working with the Stream Analytics team to make it possible to very easily export a Stream Analytics job that has been designed to work in the cloud, but to export it in a Docker container to be used on IoT Edge. So imagine you are doing some analytics on a window of time on real-time data coming from devices, and you want to extract an average on, let's say, temperature to make it simple. So Stream Analytics is pretty straightforward, and you have a SQL query language that you use to define your job, and you define inputs and outputs. Once you've done all of that, what you can do when you're actually exporting for IoT Edge is pick between cloud and edge on the UI on the portal for that Stream Analytics job, and just hit export. And then you'll get a URI for that Docker container once it's been published. And you'll see in a minute how you actually import these URI or these containers from the runtime. We also created a base image for Azure Functions. And you'll be able to use VS Code to develop a function for your scenario, which is an edge scenario, package as a container, push to a registry, and then have your edge device download that module and use it. Last but not least, we also have a streamlined way of creating Docker containers for Azure machine learning models. So you will work into Azure Machine Learning Workbench, for example, developing your Reach AI model and then exporting as a Docker container that is IoT Edge, quote-unquote, compatible, so that from IoT Edge you're able to download that machine learning algorithm and run it to do your smarts on the Edge device. So how about I show you how that works? I'm going to share my screen over here so you guys can see what's going on. And I will start some demos. So I'm on my Windows machine. My Windows machine will be my simulated edge device. That simulated edge device will need to run the runtime. To make it easier to deploy that runtime, what we did actually, we published that installer, that tool, which is AzureIoT Edge Runtime-CTL. So if I actually zoom in a little so you guys can see what I'm writing, so I did a pip install -u for updating in case I want to update an existing one, Azure-IoT-Edge was D, actually, good catch, thanks Zoom, -runtime-CTL. Anyways, I'm not going to run that because I don't want to mess with a existing configuration. But that's the concept. And that's all you need to do in order to install the Edge runtime on your box, whether you're on Linux or on Windows. Once you've done that, what you will do is run the tool IoT Edge CTL with the command start. As simple as that. What's happening there is the runtime look into the local Docker instance. Forgot to mention, you need to have Docker installed on your Linux or Windows box. So we'll check for the image of the Edge runtime. If it's not the right version or if it's not there, it will bring it down from Docker registry and it will run it. So if I look rapidly at the Docker images that are running right now, I actually have several ones. This is because I've been running a previous instance of this little guy here. Anyways, that's not a big deal. So I have this Edge runtime that is running. Let me stop it. It's going to be better. IoT Edge. Best way of restarting things. There you go. So one thing I need to do is create an IoT Edge device on my IoT Hub, right? So downloading the runtime, pretty straightforward. Starting it, you'll see it's pretty straightforward. It had a configuration because I was running a demo before, but what I want to do actually before that is create a new device. So if I go to the Azure portal, I will go to my IoT Hub instance, and there's this new section in the Explorer for IoT Edge devices. And what we'll do is just create a new IoT Edge device. I will name it Webinar Demo Edge device. I think that's a good name. And do a save here. In a few seconds, actually, I'll see this new device populated here. And what I can do with that device actually is retrieve the connection string. This is very similar to what you would do with a regular device for IoT Hub. What I want to do now is indicate to my local runtime that it needs to connect to that IoT Hub with that specific device ID. So I'm going to use the IoT Edge CTL tool, and I will do a setup of my runtime using the connection string that I just copied. And I will add another setting, which is auto cert gen force no password. We are in development environment here, and what I'm doing here, I'm telling my runtime, don't bother checking the certificates. We'll validate that with that connection string. Once again, developer environment, demo-wise, you want to use the security that is provided by the Edge runtime in a normal condition. So there you go. I configured that runtime locally on my Edge device with that specific device ID. I didn't configure any modules, so if I go like in the configuration of my device, there's nothing in there. So when I'm going to run the IoT Edge CTL start command, it will error out. So the runtime is running, but if I look at the logs of my Edge agent Docker container, what I will see is that the thing is in error because it doesn't have a configuration. It's trying to synchronize the twin and cannot find a configuration up there. So back to the portal, I'm going to start my configuration of these modules. So I'm going to hit Set Modules, and I'm going to add a new module. And defining a module is as simple as picking a name. So I'm going to call it Temp Sensor. And I'm going to pick an image that has been published on Docker registry, which is Microsoft Azure IoT Edge -simulated -temperature sensor. So demo is live, guys. It can fail. 1.0 preview, because we're in preview mode, right? So I just typed in the name of that URI, or that URI actually for that container. I'm going to hit save. So I have one module has been configured. Hit next. What I could do here eventually is define the route. I only have one module, so what I'm going to say is any data that is coming out of the modules will be sent upstream to IoT Hub. And hit next again. And then I can eventually review what happened. This JSON file is the twin, is part of the device twin actually, that the device runtime will synchronize with IoT Hub to get its configuration. I'm going to hit submit, and I'm going to go back to my device. And on the device here, I will see that the agent is synchronizing a new configuration with the cloud in order to download the missing containers and run them. So if I did everything correctly, I will see that pop up in a second here. Yep, refresh. You see here I have pending deployment for the temp sensor, and now it's running. Actually, it was so fast that things were already running down there. So what I can do now is actually look at what's going on in my Docker instance. And in Docker, I can see that I have my edge up, I have the temp sensor and the edge agent. And basically, things are running. If I look at my temp sensor module, I can see that it's sending data. And if I want to see the data coming in the cloud, what I'm going to do rapidly is cheat a little. I'm going to dive directly into VS Code, and I'm using one of the extensions I'm going to mention soon. I see my edge device here, and I do a right-click, and I'm going to start monitoring device-to-cloud messages. So from VS Code, I'm able to see what's coming up in the cloud in IT Hub, and I can see here I have my messages that are coming from my temp sensor that have been routed by the edge runtime all the way upstream, right? So all good, pretty straightforward, a bit manual, but you see the concept that is pretty straightforward of configuring an edge device from IoT Hub to determine which container it needs to run and how they need to communicate with each other. So let's actually complexify that a little. Now I want to run machine learning on my edge device, right? That's the title of the session, so I thought it was interesting to eventually do that for real. With the integration with the machine learning tools, we are able to export a container that will be compatible with edge runtime directly using the Azure ML command line tools. So right here, I have the Azure Machine Learning Workbench. And in there, I loaded a tutorial, which is actually part of the AI Toolkit IoT Edge. Let me actually zoom real quick in here. So if you search for AI-toolkit-IoT-Edge on GitHub, you'll find a full repo for that toolkit that provides instructions and samples on how to create machine learning models in the form of IoT Edge modules to run them on IoT Edge devices. So I didn't invent that. I'm just reusing an existing sample, which is the IoT Edge anomaly detection. And basically, we have a couple of Python files, and these Python files are the algorithm itself. So I'm not a machine learning guy, so I'm not going to go in there, but the idea is to determine there's an anomaly on a set of data that is passed as an input, and we're using some fancy algorithm to do that, and we score that data to determine if that data is with an anomaly or not. In order to create the container, I had to use these Azure ML command line. So I created a service that will do real-time analytics using the configuration file for the model, which is model.pkal, and the code, which is in that IoT Score Python file. And then I'm publishing that into a specific service, which is basically the place in ACR in the Azure Container Registry where I'm going to push that container. So I've done exactly that, and what I have now in my Azure Docker container, I have this repository where I have this machine learning module, and this machine learning module, because I've been iterating, has 4 versions, and here there's that public URI, actually not public because I'm logged in, so I can secure my development and my modules. So I have this module here that is a Docker container image that I'm going to use on my device. So I'm going to go back for that to my configuration of my device to add a new module. So going back to set modules, I'm going to add an IoT Edge module. I'm going to call that module machine learning module, and the URI will be the one I just copied, right? The machine learning module 4. I'll hit save, and I see now I will have temp sensor and machine learning module, right? I'll hit next, and here I need to define a route. And so to do that, there's going to be some typing involved. The first route I'm going to define, I'm going to call that route 1, for example, and I'm going to go from the messages from modules, and that's going to be the temp sensor I'm interested in. I'm going to look at the outputs of that temp sensor, and I'm going to pick all the outputs because anyways, I need all of them. and there's only one. I will go into the brokered endpoint, which is in that place, which is /modules /machine learning module, right? That's the name I just used for defining my module. Inputs /AML input. That's the way we are identifying that one input on that module here. And I'm going to close that here and that and here. Okay, so here I have my first rules, machine learning. We're almost doing a switch here. Module /outputs start. And here I want to bring that or send that into $upstream. And if I've not done any typo here, what's going on is that I'm getting all the data coming out of the temp sensor, sending them into the input of the machine learning module, and then it's been scored. And from the machine learning module, I will actually send that upstream to IoT Hub. And I will submit that to my device, and my device automatically will actually pick that up. And I will see that very soon I'm going to have a new module that's going to be deployed on my device. I'm doing a Docker PS, and at some point I will have this guy appear here. And to see what's going on, because, you know, I can be prompt to errors, I can actually check out the Edge agent logs to see if it's actually successful in downloading the machine learning module. And I'm going to scroll all the way down to this long list of logs. And once I'm all the way down there, I will see what's going on. So it seems like it started deployment, and it's actually picking that new machine learning module 3, and we'll end up having this deployed. So for the sake of time, I'm going to switch back and verify that things are working. So here, if I go back to my device, I see that I have this pending deployment for machine learning. And, you know, real life here, I'm seeing that things are not working exactly like I want. And this is something I can actually fix by restarting the runtime, I guess. It's like computers, you know, just hit them or you hit restart. And I don't want to hit my little IoT Edge device here. So I just restarted the agent. But you get the idea. It will go back online. It will bring the various containers. And once it's started the machine learning one, we'll see the type of data coming up into the cloud being different. So I'll skip that part and go to the next point, which is we've done that manually. And what I want to show you now is doing that with a little bit more of help, which is using Visual Studio Code. So I'm going to put that aside for now and bring up Visual Studio Code. The first thing I want to bring up here is the various extensions that you have available for creating your Edge devices. Let me actually stop this guy here, stop mirroring my device to cloud messages. Okay. In the extensions catalog, you will find two interesting extensions. The first one is the AzureIoT Toolkit. So that extension will allow you to interact with IoT Hub. I'll show you some of the features here. The second one is the IoT Edge extension, and that one actually adds to the first one the functionality specific to IoT Edge. If you're not familiar with VS Code, I invite you to go discover it because it's a very powerful tool that you will want to use to interact with IoT Hub and with IoT Edge devices. You don't have to, but it really simplifies your life. So let me show you how. So here's one of the first thing I'm going to do. Here in the IoT Hub extension, I can see my list of devices. I have a bunch of devices that are deployed. When you look at the first icon here, let me zoom again. This little icon here shows an actual device. And this other one, this fancy one with a cloud on top, is the IoT Edge icon. Let me actually add a new device. So I can create an Edge device directly from the UI. But what I like to do as well is go into the command panel, because everything is up there. And I can actually create a new device or create an IoT device using the IoT command, or actually go to Edge and do create Edge device. And it will prompt me for a new name. I will call that Edge device, doesn't matter, 2, for example. And it will add this device to IoT Hub. And here I have the report of that device. It's here. There's nothing running on it yet, but I can now set up my edge infrastructure locally to connect with that device ID, right? So actually, let me stop the runtime first. It is running in the back here. So I'm stopping the previous demo from running. Felicia was actually doing some machine learning stuff, but I want to make sure I'm not colliding with the other demo. So as soon as it stopped, what I'm going to do is I'm going to configure my edge runtime to use that new device ID locally. So I'm going to do a setup edge, and I'm going to pick the one I'm interested in, and that's the edge device 2 that I just created. And you'll see here in the terminal of VS Code that it's actually implementing the long command that I had to manually type in my first part of the demo, that now it's fully automated. So right now, I have my runtime running locally as soon as I do start actually. So let me do edge, start, edge. And this is where I will see the container being created and running locally. I'm using also the Docker extension for VS Code. It's really practical because actually I can go look at the various containers that are running. I can see their state. And I can actually do something such as right-click and do show logs here. So that's pretty powerful because within VS Code, I can do all the things that you would expect to be doing manually or in the portal or with command lines. But everything here is in UI-based. Now, I want to, spoil a release I'm going to have in a couple of weeks from now, so don't search for that right now. But we are actually about to release a new version of the Edge extension for VS Code that adds the possibility to work with several modules in a solution. And what you will get with that is a new set of commands, and the first one is called New IoT Edge Solution. It's going to ask me to create a new folder somewhere. So let me actually go here in a folder called, for example, Edge Demo, and I'm going to create under Edge Demo. And it's called Edge Solution 2, for example. That's my project, and I'm going to start with a module which will be a C# module. That's a custom module I'm going to create, and I will call that Filter module, for example. As an example, and what I want to do is whether run it locally, whether actually run it from or push it as a container to a registry. And so here I'm using my name, and I'm going to push to filter module. That's a Docker container registry that I own, and I'm going to push these containers that are created on my machine up to this registry. So the Visual Studio Code extension is creating the new solution, opening it, and what I will see in there is the code for the module, and I will see also the Docker file to create the Docker container, and basically everything that I need to rapidly iterate on my developments. In the deployment template JSON file, I will see that the definition of this Docker container, or actually of my Edge program or application, will contain the various modules that are the system ones, the agent and the Edge hub, and then we'll have this temp sensor and filter module. Temp sensor as an example. We're in the hello world here, and this is my filter module I just created. And so this definition here, what I need to do in order to create a Docker container based on that program CS file code here, which is basically a pass-through of all the data. You will be able to play with that in a couple of weeks from now, once again. For each messages that are coming into that module, I'm just piping them out by adding something to the content. So that's a very simple example. That's the yellow word of a module. What I need to do from the UI again is actually right-click on this deployment template JSON and hit Build IoT Edge Solution. And what's going on here is that I'm compiling the .NET Core application as a module using the SDK. I'm creating the Docker container, and then I'm going to push to that Docker registry. We'll see how long it takes. I might actually skip that and go to the next point. It seems that it has actually been pushing that pretty straightforward. What I can do actually now is try it, right? So in the config folder, it has created a deployment.json file, which is, you'll notice, the exact same thing as the output of my configuration of modules for a device in the portal when I'm creating my deployment. Let me actually now go to the IT Hub devices. I will select my Edge device 2 that only has the runtime, and I will select the create deployment for Edge device. And this one actually is asking me for a specific JSON file, which is that deployment.json. So what I'm doing right now from VS Code is I'm going to push that deployment configuration, these lists of modules and the routes, to the IoT Hub registry for that very device ID of this Edge device 2, right? So I don't need to go through the portal to do that. I can do that from VS Code directly. So let me pick that one. So it's starting it's creating that JSON file, sending it out to IT Hub, pushing for that specific Edge device. And once that is done, what I can do actually is verify that everything is there as I'm claiming, so that you guys can see that I'm not just making things up. I'm going to refresh the list of devices here, and I will see the Edge device 2 that's been showing up in my list. And in here, I can see that now I have the temp sensor and filter module that have been set up as modules. And back to my device, I'm not sure whether I started that Edge instance, so I can actually do start Edge, which has been set up for that Edge device 2. And I can look on the Docker extension what's going on in terms of containers that are deployed and images. And I can see now that I'm locally running the Edge Hub, I'm locally running the Edge agent, and I also have the simulated temp sensor and my filter module that has just compiled and deployed to a Docker registry, and in my case, because I'm simulating on my device, re-downloaded to my device. All of that with a few command lines and right clicks in VS Code. That was pretty straightforward. One thing that I want to spoil as well a little bit is the notion of debugging. So this is something that will certainly be a matter of a new webinar or some IoT show episode, but you will be able to do debugging into your code directly from VS Code of a module running into a Docker container. So that's going to be super powerful, but once again, topic for a next webinar, hoping that you enjoy this one. So let me go back to my slides for a minute, stopping sharing here, and allowing you to learn some more and then ask some questions. So the first thing I want to point you to is to learn more about AzureIoT Edge. You go to aka.ms/azure-iot-edge. If you want to learn how to get started and look at the various tutorials, some of them I've just run or part of them I run today, go learn yourself, aka.ms/azure-iot-edge get started. So that's your starting point for anything Azure IoT Edge. And we'd like to hear from you guys in terms of the experience there. I'll look at the Q&A in a second, and hopefully for those who were not answered, we can spend some time on answering them.
Thank you, Olivier. So we have about 10 minutes left to the top of the hour, and I will hand it back to Olivier just in a moment to answer a few of these questions live. In the meantime, if you could just remember to fill out the survey at the end of the webinar so that we can get some additional information from you, that would be excellent. And the resources that were mentioned on the last slide can be found in your resources console on the webinar, top corner of your webinar console. Olivier, I'll hand it back to you.
Yep, no problem. Actually, in the answers, I don't know if we have some other people in the team actually answering live, which is great. Thanks to Paulo and team. There's one question about Docker only runs on Linux, so it's Windows containers on Windows, correct? Actually, that is not correct because Docker runs on Windows, and you have the option. So you can pick, Docker on Windows or on Linux for running your IoT Edge device, and that will be possible. In terms of heavyweight, that's Docker. So we're talking about running compute. Docker in itself is not something that is like super heavy. It's something that's pretty smart in terms of technology, not something I'm going to dive in right now, but this is something that you can leverage on tiny devices. Then the workload and the weight of your modules will depend on what you're doing there. If you are running a full-blown, Vision API algorithm, yes, it will require some room in RAM and some, maybe GPU, whatever. But that all depends on the type of processing you want to do there.
We had someone just ask if we could put up the AKA address again, so I went ahead and moved back to the resource slide, so that's up here on your screen as well.
Cool. So how about I pick another? Is module twin part of device twin? That's a good question. The module twin is indeed something that actually is unique to the module itself. I think there's been an answer by someone, that's me actually answering, and Pamela is tagging as answered. I invite you to actually go to our documentations because there's going to be a lot of details in terms of understanding module twin, device twin. There is a module twin for each of the modules, which are unique to each of the device. So basically, you have a module twin per module deployed on a device. Okay, so in terms of clarifying, so IoT, Edge, Hub, modules, runtime, the session directly dove into IoT Edge itself, assuming that you guys already had good notions about what a Hub is and so forth. Let me sum that up in 10 seconds. Azure IoT Hub is a cloud-based service that allows you to manage and communicate with devices in the field. IoT Edge is a runtime running on a device that will allow you to control software running on that device from the cloud through IoT Hub. The runtime is what runs on the device itself. The modules are software entities that are running on an edge device and they are configured from the cloud through IoT Hub. So we have way more documentation. I invite you to check out our IoT show on Channel 9 that has tons of explanation about what is IoT on Azure, what is Hub, what is Edge, and so forth. So you'll learn way more in there. Quick other question, can I send commands to the module? Yes. Short answer is yes. You'll be able to send what we call direct methods to a specific module. So you can send commands the same way you would do for devices, but in that case for specific modules. And modules, they are addressed in IoT Hub in the form of device ID/module ID. So you can address a very specific module on a very specific device. And then what you can do is use query and jobs on top of IoT Hub to address a multitude of devices at once. So you can actually batch your commands to plenty of devices running the same module. Interesting question about IoT Central. So question is IoT Central, question mark. IoT Central is a SaaS offering for IoT that is based on IoT Hub, and that will be, when it's out of preview, compatible with IoT Edge devices. So for now, IoT Central targets basic devices. It leverages IoT Hub as a service under the hoods, and you can connect devices to IoT Central the way you would do with IoT Hub, but you get a full SaaS solution with data analytics and dashboarding and user management with IoT Central. Once again, very interesting Channel 9 IoT show video that is out there. And because I've been talking about this one, there is a URL for the IoT show on Channel 9, and this is aka.ms/ch9 IoT show. CH9 IoT show on aka.ms. That's the URL for the Channel 9 IoT show. Another couple questions before we hang up and ask you guys to, there's lots of questions, very interesting. Can IoT Edge containers be integrated with Kubernetes? I will leave it open for now, the question, because that's a very interesting question that will require more time to answer, because the answer is it depends. So let's follow up. If you guys want to send some direct emails, I'll be happy to route that. Oh, interesting question from our friend from Beckhoff here. Are Azure certified devices also IoT Edge certified? Short answer is no. because actually the Azure certification for IoT today is for connecting using one of our device SDKs and doesn't require running Docker and whatever. This is something we have in preparation and that we are looking into, and you'll hear more once we go in general availability. Is there a GA date and target? Not official, so I cannot answer that question. Let me pick a last one. Sorry for the questions that are not answered. Once again, we can answer over email if you guys want to ping me and totally spam my email address. Just feel free to do that. And I'll make sure that I get answers to all of you guys. Do we need any on-premise server to get data from PLC devices to stream analytics? So if your question is about what do I need to do to hook up to a PLC device using IoT Edge, I think the best answer I can give you is, well, first, it depends on what protocol your PLC is running on. If it's OPC UA, for example, you will need to have an OPC UA module on your IoT Edge device, which we happen to have. You can find more information looking online for IoT Edge, Azure IoT Edge, and OPC UA. I think we have an open source version of that module. So once you retrieve the data from that PLC, then you can integrate that into your analytics. So you can actually dump a streaming analytics job on your Edge device to do the analytics on that data coming from the OPC UA network. There's way more to that in terms of answer, but this is the baseline here.
All right. It looks like we are at the top of the hour. I have a few questions coming in regarding the slides and our recordings. You will get a recording of this webinar in your email in the next 24 to 48 hours, so be sure you are on the lookout for that email. We do not provide the slide deck directly right now, but you can certainly rewatch the recording at your leisure. So with that, we will go ahead and wrap it up today. Thank you so much for joining us, and we hope to see you at another upcoming webcast.